The night sky isn't just a scattering of stars, it's a silent archive of cosmic secrets, each one a puzzle waiting to be unraveled. Right now, hidden in the vast expanse of space, there are phenomena so bizarre they defy everything science thinks it knows. Take dark matter, an invisible force holding galaxies together, yet no one can say what it actually is. Or consider the eerie quiet of the cosmos. Where are all the alien civilizations we expected to find? These aren't just curiosities, they're clues to the universe's greatest mysteries, some dating back to its very birth. Today, we're diving into 23 of these enigmas, from the edges of black holes to the echoes of the Big Bang. And here's the startling truth: the more we discover, the more we realize how much remains unknown. This isn't just a tour of the cosmos, it's a glimpse into the questions that could redefine reality itself. Picture holding a snow globe, except instead of water and glitter, it's the entire universe swirling inside. Now imagine that 85% of what's in that globe is completely invisible. That's the unsettling truth about dark matter. We know it's there because galaxies spin like they're being gripped by unseen hands, and light bends around empty patches of space as if tugged by hidden weight. Yet after decades of hunting, we've never caught a single particle of it. Theories abound, from exotic particles that barely interact with regular matter to eerie possibilities like parallel universes leaking gravity into ours. Underground labs have set up ultra-sensitive detectors, waiting for a whisper of dark matter passing through Earth. Space telescopes map its ghostly fingerprints by tracing how it warps the paths of distant starlight. And still, it slips away. What makes this even stranger? Without dark matter, the cosmos as we know it wouldn't exist. Those vast webs of galaxies, the slow dance of cosmic structure, none of it adds up unless something invisible is holding everything together. Some scientists wonder if we've misunderstood gravity itself, that the rules we've trusted since Newton might need rewriting. Others think dark matter could be just the first clue to a hidden layer of reality, one where the universe's true nature is nothing like we've assumed. Every failed experiment, every unexplained observation pulls us deeper into the mystery, because if dark matter isn't what we've theorized, then what exactly have we been missing? If dark matter is the universe's invisible scaffolding, then dark energy is the unseen architect, one that's actively demolishing the blueprint. Imagine blowing up a balloon with galaxies painted on its surface. Now picture the balloon inflating faster and faster until one day, those galaxies vanish over the cosmic horizon, forever out of sight. That's the unsettling reality we face. Space itself is stretching apart at an accelerating rate, and no one knows why. This cosmic shock came in 1998 when two teams studying distant supernova made an impossible discovery. These exploding stars, used as cosmic mile markers, were dimmer than expected, meaning space had stretched more than predicted since their light began traveling billions of years ago. The conclusion, some repulsive force, later named dark energy, is overpowering gravity's pull, flinging galaxies away from each other like debris in an explosion. What makes this force so baffling is its sheer dominance. Dark energy accounts for 68% of the universe's total energy, yet its nature remains elusive. Einstein once proposed a similar idea with his cosmological constant, a mathematical fix he later called his greatest blunder. Could he have been right after all? Or is dark energy something stranger, like a shifting quantum field dubbed quintessence? Some physicists even wonder if gravity itself behaves differently across cosmic distances, a flaw in Einstein's equations we've yet to uncover. The stakes couldn't be higher. If this acceleration continues unchecked, distant galaxies will eventually vanish from view, leaving our descendants with a sky devoid of stars. The universe would end not with a bang, but with an icy, isolated whisper, the Big Freeze. Yet for all its apocalyptic implications, dark energy might hold clues to deeper truths. Could it be tied to the vacuum of space itself, a seething quantum foam of particles flickering in and out of existence? Or is it evidence of extra dimensions leaking energy into our own? Every measurement we take deepens the riddle. The Hubble and James Webb telescopes scrutinize distant supernova, while galaxy surveys map the universe's expansion in 3 dimensions. Still, dark energy slips through our grasp like smoke. One thing's certain, solving this enigma won't just reveal the universe's fate, it might rewrite the laws of physics as we know them. And speaking of rewriting physics, few places challenge our understanding more violently than the swirling maw of a black hole. At the heart of cosmology lies a paradox. We can trace the universe's history back nearly 14 billion years to a single, infinitely dense point and still hit a wall. The Big Bang marks the moment everything began, but not the why. Like a detective arriving at a crime scene after the explosion, we sift through cosmic debris, the afterglow of the Big Bang in the form of microwaves, the fingerprints of primordial elements, yet the trigger remains missing. The leading model, cosmic inflation, suggests the universe expanded faster than light in its first sliver of existence, smoothing irregularities into the vast cosmos we see today. But what ignited that hyper-expansion? Some theorists propose quantum fluctuations, that our universe is just one bubble in an endless froth of space-time, where random energy shifts spawn entire realities. String theory offers another twist. Colliding membranes or brains in higher dimensions might have sparked creation like symbols clashing in the dark. Even stranger, the Planck satellite's map of the cosmic microwave background, the oldest light in existence, reveals puzzling irregularities. Some regions appear oddly colder than they should be, as if our universe bears scars from something before the Big Bang. Could time have stretched backward in a mirror universe, with ours emerging from the collapse of a previous cosmos? This cyclical model, where universes bounce endlessly between expansion and contraction, tantalizingly solves one riddle while introducing others. What's at stake isn't just the origin story of our universe, but its very uniqueness. If the Big Bang wasn't a singular event, but one of countless cosmic rebirths, then reality might be vaster and stranger than we've dared to imagine. And if time itself behaved differently before creation, our most fundamental laws, causality, entropy, even the arrow of time, could be local quirks rather than universal truths. Yet for all its mystery, the Big Bang's lingering questions unite physicists and philosophers alike. They remind us that science's greatest power isn't having answers, it's daring to ask what lies beyond them. And if there's one place where the boundaries of knowledge dissolve entirely, it's lurking in the gravitational grip of a black hole. Black holes don't just crush matter, they might be erasing the very fabric of reality itself. Here's the terrifying dilemma. When an object crosses a black hole's event horizon, general relativity says it's gone forever, stretched into oblivion by tidal forces. But quantum mechanics insists that information, the fundamental blueprint of every particle, can never be destroyed. So which is it? Does the universe keep perfect receipts of everything that falls in, or does the cosmos have cosmic amnesia? Stephen Hawking's groundbreaking work in the 1970s only deepened the mystery. His theory of Hawking radiation showed that black holes aren't completely black. They slowly leak energy and particles, eventually evaporating entirely. But here's the kicker. If a black hole vanishes, what happens to all the information it swallowed? The math suggests it disappears too, violating quantum theory's sacred rule that information must be preserved. Physicists call this the information paradox, and it's been keeping them awake for decades. One radical solution comes from the holographic principle. which suggests that all the data about infalling objects isn't lost, it's smeared across the black hole's event horizon like a cosmic hard drive. Picture throwing a book into a fire, but instead of burning away, its words get imprinted onto the flames themselves. Others propose even wilder fixes, like firewalls of high-energy particles at the horizon that instantly vaporize anything approaching, a notion so controversial it splits the physics community down the middle. At stake is more than just black holes. If information can truly vanish, our understanding of cause and effect, the orderly sequence of the universe, crumbles. Some researchers suggest this paradox hints at an even deeper truth, that space-time itself might be pixelated at the tiniest scales, woven from indivisible fragments like a cosmic digital image. Others speculate we're seeing the first cracks in Einstein's theory of gravity, evidence that relativity and quantum mechanics must merge into some grander framework we've yet to discover. The irony: the closer we look at black holes, the more they resemble cosmic mirrors, reflecting back the limits of our knowledge. And just when we think we've grasped the rules, the universe throws another curveball, like the enigma we'll explore next, where reality seems to defy its own laws in broad daylight. The cosmos should be teeming with voices, with hundreds of billions of galaxies, each brimming with planets in habitable zones. The numbers alone suggest we shouldn't be the only ones here. So why does the universe feel so hauntingly empty? This is the Fermi Paradox, the glaring contradiction between the high probability of alien civilizations and the total absence of any evidence they exist. Enrico Fermi first posed the question in 1950 during a casual lunch conversation. Where is everybody? 7 decades later, that query still echoes through every silent radio telescope scan, every fruitless search for extraterrestrial artifacts. We've combed the skies for laser pulses, listened for structured radio signals, and even scanned distant atmospheres for industrial pollution, yet the answer remains the same. Silence. Some theories paint a chilling picture. The dark forest hypothesis suggests advanced civilizations stay quiet to avoid attracting predatory rivals like hunters tiptoeing through a cosmic woodland, terrified of giving away their position. Others propose the Great Filter, an evolutionary or technological barrier so lethal that almost no life survives it. Are we before the filter, lucky survivors who will eventually hit a catastrophic wall? Or are we past it, meaning complex life is rarer than we dared to believe? Then there's the unsettling possibility that intelligence itself is a dead end. Maybe civilizations inevitably collapse under climate change, warfare, or runaway AI before achieving interstellar travel. Or perhaps physics itself conspires against expansion, with light speed limits making galactic empires impractical. A few scientists even entertain the loneliest idea of all, that we're the universe's first or last spark of awareness in an otherwise lifeless void. But here's the twist: absence of evidence isn't evidence of absence. Our searchers have barely scratched the surface. Imagine an ant on a single blade of grass trying to deduce the existence of New York City. The truth might be hiding in phenomena we can't yet perceive, like civilizations harnessing dark energy or transcending into digital realms beyond our detection. This cosmic silence isn't just a puzzle, it's a mirror. Whether we're alone, being watched, or simply early to the party, the Fermi Paradox forces us to confront our fragility and our responsibility as potential torchbearers of consciousness in an indifferent universe. And if the scale of that mystery feels overwhelming, wait until you glimpse the largest structure ever discovered, a cosmic colossus so vast it defies the very laws we thought governed the universe's sixth enigma. The giant arc. Just when cosmologists thought they had the universe's blueprint figured out, along comes a structure so enormous it shouldn't exist. Stretching an incomprehensible 3.3 billion light-years across roughly 1/15, The diameter of the observable universe, the giant arc, is a nearly perfect curve of galaxies, quasars, and galaxy clusters. It's not just big, it's impossibly big, challenging one of astronomy's foundational rules, the cosmological principle. This principle assumes that, at the largest scales, the universe is smooth and uniform like a well-mixed batter. Zoom out far enough and matter should distribute evenly with no colossal patterns or asymmetries. Yet the giant arc defies that. Its sheer size suggests a cosmic unevenness, as if the universe's scaffolding has a hidden warp. The odds of such a structure forming by random chance, less than 1 in 20,000. So is it a statistical mirage or something far stranger? Some theorists argue it's a temporary illusion, a chance alignment of unrelated objects seen from our vantage point. Others see darker possibilities, an imprint from before the Big Bang, perhaps, or evidence of exotic forces like cosmic strings, hypothetical defects in space-time left over from the universe's birth. These ultra-dense scars could have twisted matter into unnatural shapes as the cosmos expanded. The stakes go beyond one strange structure. If the giant arc is real, it implies that the universe's largest features aren't random but follow rules we haven't uncovered yet. Current models of structure formation, based on dark matter's gravitational pull, can't easily explain how something so vast and coherent could emerge so early in cosmic history. It's like finding a skyscraper in the middle of the Stone Age, an anachronism that rewrites the timeline of how complexity grows. Telescopes like the Sloan Digital Sky Survey first spotted the arc by mapping millions of galaxies, revealing patterns invisible to the naked eye. Future observations will test its reality, whether it's a true cosmic curveball or a trick of perspective. But if confirmed, the giant arc could force us to reconsider not just the universe's architecture, but the very laws governing how it took shape. And as if that weren't disorienting enough, another ancient anomaly looms, even larger one written in the fading glow of the universe's first light, seventh Enigma, the CMB Cold Spot, a cosmic bruise. Buried within the afterglow of the Big Bang lies a blemish so peculiar it might rewrite our understanding of reality. The cosmic microwave background, the oldest light in existence, isn't perfectly uniform. Most variations are tiny, mere whispers of density fluctuations from the universe's infancy. But one anomaly stands out, the cold spot. Stretching nearly 2 billion light-years wide, this region is chillingly colder than its surroundings by about 70 microkelvin. Not much on paper, but for cosmologists it screams something's wrong here. At first glance, it could be a cosmic void, a vast, empty bubble where matter inexplicably thinned out. But simulations show such voids shouldn't grow this large or leave such a stark thermal imprint. The cold spot's edges are too sharp, its drop in temperature too extreme. It's like finding a freezer door left open in the Sahara, an outlier that defies natural expectation. This is where the theories take a surreal turn. Some physicists suggest the cold spot could be evidence of a collision with another universe. In the multiverse scenario, where countless bubble universes sprout from an eternal cosmic foam, our universe might have bumped into a neighboring one long ago. The energy discharged in that collision could have left behind a scar, a patch of space cooled by the encounter. Imagine two soap bubbles brushing together. The dent where they touched lingers long after they separate. Others propose even wilder explanations. Could it be a knot in spacetime itself, a relic from dimensions beyond our own? Or does it hint at dark energy behaving differently in certain regions, subtly warping the fabric of reality? The cold spot refuses to fit neatly into any single theory, which makes it irresistible to researchers. The European Space Agency's Planck satellite has scrutinized this anomaly, yet its origin remains contested. Future missions like NASA's upcoming Lightbird satellite aim to analyze the CMB with unprecedented precision, searching for polarization patterns that might confirm or debunk these radical ideas. Whatever the truth, the cold spot forces us to confront an electrifying possibility that our universe isn't solitary. It may bear marks of unseen neighbors, of realities brushing against ours in the dark. And if that's the case, the greatest cosmic shockwaves might still be hiding in the static between worlds. But while some anomalies tease us with hints of other universes, others strike closer to home, like the eerie objects orbiting our own sun, defying every rule of celestial mechanics. Eighth Enigma. Fast radio bursts the universe's unexplained heartbeats in the quiet hum of interstellar space. Something extraordinary is happening. Without warning, a burst of radio waves packing more energy than the sun emits in days flares across the cosmos and vanishes in less time than it takes to blink. These are fast radio bursts, or FRB, and they're among the most baffling signals ever detected. Like cosmic Morse code from galaxies billions of light years away, they flicker into existence, then disappear, leaving astronomers scrambling for answers. What makes FRBs so captivating isn't just their power, it's their sheer unpredictability. Some explode once and never repeat, like a firework lighting up the dark. Others, like the infamous FRB 121102, flicker on and off in erratic patterns, as if controlled by an unseen cosmic switch. The leading suspects, magnetars, highly magnetized neutron stars that could unleash flares so intense they ripple across the universe. But not all FRBs fit this explanation. Some pulses arrive with bizarre substructures, splitting into multiple peaks, as if encoded with layers of information. Then there's the wild card. Could some of these bursts be artificial? The idea isn't as far-fetched as it sounds. In 2017, a Harvard team floated the possibility that FRBs might be leakage from alien light sails, massive energy beams propelling interstellar spacecraft. Others speculate they could be cosmic lighthouses, deliberate signals from advanced civilizations. The truth, we have no definitive proof, just a growing catalog of anomalies that refuse to conform. What's even stranger is that FRBs aren't just distant curiosities. In 2020, astronomers detected one inside our own galaxy, erupting from a known magnetar. This was a smoking gun, proof that at least some FRBs stem from these extreme stellar remnants. Yet the mystery deepens. Why do some repeat while others vanish forever? And how do certain bursts travel billions of light years without scattering into noise, as if guided by an invisible hand? The hunt for answers is accelerating. Telescopes like CHIME in Canada scan the skies daily, catching FRBs in real time. Each new detection peels back another layer, revealing twists like bursts with circular polarization, hinting at extreme magnetic environments. But with every breakthrough comes new questions. Are FRBs cosmic accidents or something more deliberate? Could they be remnants of long-dead stars or even echoes of physics we've yet to discover? One thing's certain, these fleeting radio whispers are forcing us to rethink how energy moves through the universe. And just when we think we're close to cracking their code, they surprise us all over again. Much like the next enigma we're about to explore, where the very laws of physics seem to bend. Ninth enigma, the WOW. Signal a 72-second cosmic whisper for 47 years. Astronomers have been haunted by a single line of scribbled data. On August 15, 1977, Ohio State University's Big Ear radio telescope recorded something extraordinary. A burst of radiation so unusual that researcher Jerry Amon circled it on the printout and wrote one word in the margin: wow. The signal lasted just 72 seconds, blazing at a frequency of 1,420 MHz, the precise wavelength where hydrogen, the universe's most abundant element, naturally emits energy. It came from the direction of the Sagittarius constellation, packed with stars but no known celestial objects that could explain it. Most telling, it was narrowband, meaning all its energy was focused into a tight slice of the radio spectrum, a telltale sign of artificial origin. Natural cosmic noise spreads across frequencies like static. This was a laser-sharp spike, the kind you'd expect from a transmitter, and then nothing. Despite decades of follow-up scans, the WOW signal never repeated. It remains the most tantalizing and frustrating anomaly in SETI history. Was it a message from an alien civilization briefly flickering into our detection range before vanishing? A military satellite stray transmission? Or something more mundane, like a comet's hydrogen cloud reflecting radio noise? The comet theory gained traction in 2017 when researchers suggested that two icy bodies passing through the area might have mimicked the signal. But skepticism lingers. Comets don't typically emit such focused, powerful bursts. Others argue it could have been an Earth-based signal bouncing off space debris, though no matching broadcasts were ever identified. What's undeniable is the WOW signal's cultural impact. It crystallized humanity's yearning to answer Fermi's paradox, proof that if we listen long enough, the cosmos might whisper back. Modern projects like Breakthrough Listen now scour millions of frequencies simultaneously, armed with AI to flag anomalies in real time. Yet that 72-second Enigma stands alone, a cosmic flare that dared us to wonder, were we heard? Perhaps the truth lies somewhere between hope and physics. If the signal was artificial, the civilization behind it might be long gone. Their beacon now just echoes in the void. Or maybe we're the ones who blinked, our telescopes turned away when they called again. Either way, the WOW signal reminds us that the universe isn't just a spectacle, it's a conversation waiting to happen. And if decoding a fleeting radio burst feels daunting, wait until you meet the solar system's own rebel, a world orbiting backward in defiance of gravity's rules, a 10th Enigma. Planet 9, the solar system's ghostly giant beyond Neptune's icy realm. Something enormous is pulling the strings. Scattered across the frigid outskirts of our solar system, a group of small icy bodies orbits in eerie alignment, their paths tilted, clustered, as if nudged by an unseen hand. These Kuiper belt objects shouldn't behave this way, unless something massive is out there warping gravity's rules. Enter Planet 9, a hypothetical world up to 10 times heavier than Earth, lurking in the darkness. The evidence is written in celestial math. Caltech researchers first noticed the odd orbital patterns in 2016, calculating that only a distant, super-Earth-sized planet could explain them. Its gravity would act like a cosmic shepherd, herding these frozen objects into strange configurations. Yet despite years of searching, no telescope has spotted it. Is it a stealthy ice giant reflecting almost no light, or something even stranger like a primordial black hole, no larger than a grapefruit but weighing as much as a planet? The hunt has taken astronomers to bizarre frontiers. Some scan the skies for faint heat signatures, while others track gravitational microlensing, brief flashes that might betray a black hole's presence. There's even a citizen science project, Backyard Worlds, where volunteers scour telescope data for moving dots. Every clue leads to more questions. Why wouldn't such a large planet have been detected during formation? Could it be a rogue world captured by the sun's gravity? Or is it a glitch in our models, a cosmic coincidence masquerading as a mystery? Meanwhile, the Kuiper belt keeps surprising us. In 2023, the discovery of 12 more oddly aligned objects strengthened the case for Planet 9's influence. But skeptics argue these patterns might stem from collective gravitational tugs or remnants of an ancient collision. The truth may lie with upcoming observatories like the Vera Rubin telescope, set to map the sky with unprecedented depth. What's at stake isn't just another planet. Finding or debunking Planet 9 could rewrite solar system history. Was there once a fifth gas giant flung outward during chaos billions of years ago? Does this explain Earth's unusual tilt, or are we seeing shadows of physics we don't yet grasp? Until we spot this phantom world, one thing's certain: our cosmic neighborhood still holds secrets waiting in the dark. And while we search for hidden giants, another enigma tugs at the edges of reality, one where particles seem to defy the very fabric of space-time. 11th enigma. Panspermia, the cosmic seeding of life. Picture a dandelion releasing its seeds into the wind, except instead of a breeze, it's the vacuum of space, and those drifting spores are hardy microbes clinging to a comet. This is the radical idea behind panspermia, the theory that life didn't begin on Earth at all. Instead, it might have arrived here as a cosmic stowaway, hitching rides on asteroids or comets that crashed into our young planet billions of years ago. The evidence is stranger than fiction. We've found extremophiles microbes thriving in Earth's most hostile environments, from boiling hydrothermal vents to the freezing deserts of Antarctica. If life can endure here under such extremes, why not in the icy depths of space? Even more compelling are the organic molecules discovered inside meteorites: amino acids, the building blocks of proteins and nucleobases, the letters of DNA's genetic code. In 2020, researchers even spotted glycine, the simplest amino acid, in the tail of Comet 67P, captured by the Rosetta spacecraft. Could these fragments be the universe's way of distributing life's raw materials? Some experiments suggest bacteria like Deinococcus radiodurans can survive years of radiation exposure in space, while others show microbes clinging to meteorite surfaces in simulated interstellar conditions. There's even a wilder twist directed panspermia, the notion that an advanced civilization might have deliberately seeded life across galaxies, though that ventures firmly into sci-fi territory. But panspermia doesn't just challenge where life began, it reshapes how we search for it. If microbes can drift between stars, then planets like Mars or Europa might share a common ancestor with Earth, hinting that life elsewhere could be eerily familiar. Alternatively, if life arose independently in multiple places, the universe could be a mosaic of unrelated biologies. Either way, the implications are staggering. We might all be descendants of interstellar travelers, and Earth just one fertile stop on a galactic migration route. Yet for all its allure, panspermia doesn't solve life's ultimate mystery, it just pushes it farther into the cosmos. Where and how did those first living molecules assemble? The answer might lie not in the void between stars, but in the quantum quirks of the universe itself. 12th enigma. Tabby's star, the cosmic mystery in our backyard. Most stars pulse with predictable rhythms, a steady heartbeat of light across the cosmos. But one star, nestled 1,500 light-years away in the constellation Cygnus, refuses to follow the rules. Meet Kick 8,462,852, better known as Tabby's star, named after astronomer Tabitha Boyajian, who first spotted its bizarre flickering. Unlike anything else we've observed, this star dims erratically, sometimes by a staggering 22%, as if something vast and unseen is passing in front of it. The question tore through the astronomy community: what could possibly blot out a sun-sized object like this? At first, the theories were as wild as the data. The most tantalizing, an alien megastructure, perhaps a Dyson sphere, a hypothetical swarm of solar panels built by an advanced civilization to harvest their star's energy. Imagine a network of satellites so dense they shroud the light intermittently, like clouds drifting across the sun. It was a seductive idea, igniting headlines and speculation. But science demands more than excitement, it demands evidence. Clues soon pointed to a less sci-fi explanation, though no less puzzling. Detailed spectral analysis revealed the dimming wasn't uniform, different colors of light were blocked at different intensities. That's the fingerprint of dust, not solid megastructures. Tiny particles, maybe from cometary debris or planetary collisions, could scatter certain wavelengths while letting others through. Yet even this answer raises new questions. Where is all this dust coming from? Why hasn't it dispersed or settled into orderly rings like Saturn's? And how does Tabby's star produce hundreds of times more dust than normal stars? Some researchers suggest we're witnessing the aftermath of a cosmic catastrophe, a planet torn apart by gravitational forces, its remains now circling the star in chaotic swirls. Others propose the star itself is unstable, coughing out vast plumes of material in fits and starts. The truth might be even stranger. In 2021, observations caught the star brightening unexpectedly, as if the dust clouds had suddenly cleared. Stars don't behave this way unless the rules we've written are missing a chapter. What makes Tabby's star so compelling isn't just the mystery. It's the reminder that even familiar corners of the universe can defy explanation. With every telescope trained on it, from Kepler to James Webb, we're peeling back layers of a cosmic oddity that refuses to fit the mold. Whether it's alien engineering or nature's own improvisation, one thing's certain: sometimes the universe saves its greatest puzzles for the stars right next door. And speaking of cosmic neighbors, our next enigma takes us even closer to home, to a place where the very fabric of reality seems to unravel in real time. 13th Enigma. The Moon's magnetic mystery, a cold rock that defied physics. It's one thing to solve a mystery. It's another to realize the answer shouldn't exist at all. For decades, lunar rocks collected during the Apollo missions held a baffling secret. Locked in their ancient crystals was evidence that the Moon, our airless, geologically quiet neighbor, once had a magnetic field as strong as Earth. But here's the problem: magnetized rocks require a churning molten core to generate that field, and the Moon's core is too small, too cold, and seemingly too inert to pull that off. It's like finding fingerprints on a doorknob in an empty, locked room. So what could have powered this magnetic dynamo? One theory points to cosmic violence. Around 4 billion years ago, the Moon was pummeled by massive impacts, some so violent they might have stirred its core like a spoon in coffee, jump-starting a temporary magnetic engine. Simulations show these collisions could have delivered enough energy to liquefy parts of the core, creating swirling currents of molten metal. But there's a catch: the magnetism lasted far longer than impacts alone could explain. That's where the real enigma begins. Some scientists argue the Moon's core might have once been rich in lightweight elements like sulfur, lowering its melting point and allowing convective currents to persist for ages. Others propose the gravitational tug-of-war between Earth and the Moon. A dance called tidal heating could have kept the core simmering far longer than expected. But the most tantalizing possibility: the Moon's magnetic field wasn't homegrown at all. Instead, it might have borrowed one from Earth during an era when the two worlds were still tethered by a shared atmosphere or plasma bridge. Why does this matter? Because magnetic fields aren't just cosmic decoration, they're shields, deflecting deadly solar radiation and preserving atmospheres. If the Moon had one, even briefly, it could mean lunar volcanoes once spewed gases thick enough for transient pools of water, or that early Earth's magnetic field extended far beyond today's boundaries, rewriting the rules of planetary protection. The Artemis missions aim to settle the debate, drilling into unexplored lunar regions for more magnetic clues. But until then, this cold, silent rock serves as a reminder. Sometimes the quietest objects in the cosmos hold the loudest surprises. And if the Moon can flip the script on planetary science, what other secrets are hiding in plain sight? Speaking of cosmic rule breakers, our next enigma takes us to a world where the sky itself burns with impossible heat. 14th enigma. Venus's runaway greenhouse. Earth's evil twin. Look at Venus today, and you're staring at a planetary apocalypse frozen in time. A world nearly identical in size to Earth, yet covered in clouds of sulfuric acid that rain acid only to evaporate before touching the ground. Surface temperatures hot enough to melt lead, crushing atmospheric pressure, and winds that howl at hurricane speeds. This isn't just an alien environment, it's a warning. Venus shows us what happens when a planet's climate spirals out of control, and the terrifying part. Earth could have easily ended up the same way. So how did Venus transform from a potentially habitable world into a 870-degree Fahrenheit pressure cooker? The culprit is the runaway greenhouse effect, a chain reaction of heat trapping gone horribly wrong. Sunlight penetrates Venus's thick carbon dioxide atmosphere, warming the surface, but when that heat tries to escape, it's trapped by CO2 molecular grip. Unlike Earth, where carbon cycles through oceans and plants, Venus had no such safety valve. Volcanoes likely spewed endless CO2 into its skies, and as temperatures rose, oceans, if they ever existed, boiled away, dumping more water vapor, a potent greenhouse gas, into the air. The result, a feedback loop of escalating heat that never stopped. But here's the real mystery. What kicked this off? Some scientists suspect Venus's slow rotation. Its day is longer than its year, left its sun-facing side baking for months, jump-starting irreversible warming. Others point to a cataclysmic resurfacing event billions of years ago, where epic volcanic eruptions flooded the atmosphere with carbon in one geologic gasp. And then there's the wild card. Could Venus have once hosted life, only to choke on its own biosphere's waste? It's a grim thought that microbial metabolism might have tipped the balance toward doom. Every probe we've sent, from the Soviet Venera landers to Japan's Akatsuki orbiter, has peeled back another layer of Venus's secrets. Yet the more we learn, the more urgent the lesson becomes. Right now, Earth's CO2 levels are climbing at a rate unseen in millions of years. Venus proves that once certain thresholds are crossed, there's no going back. But Venus isn't the only sibling hiding secrets. While one planet cooked itself to death, Mars, Earth's smaller, colder brother, holds clues to the opposite extreme. A world that lost its life-supporting potential. And that paradox might be the most revealing clue of all. 15th enigma. Mars's methane spikes. Geology, life, or cosmic sleight of hand. Mars has been playing a dangerous game of hide and seek with scientists for years, and the stakes couldn't be higher. On Earth, methane is a gas with two faces. Most comes from living things, cows, decaying plants, even microbes deep underground. But it can also seep from volcanic vents, a product of sterile chemical reactions. So when NASA, a Curiosity rover, detected methane puffing into the Martian atmosphere, sometimes in sudden, fleeting spikes, it set off a firestorm of debate. Could this be the first whiff of alien life? The mystery deepens with its bizarre timing. These methane bursts aren't constant, they fluctuate with the seasons, peaking during Martian summer and vanishing in winter. That kind of rhythm hints at something active beneath the surface, like microbial colonies waking and sleeping with the planet's temperature shifts. But before we jump to extraterrestrial biology, there's a plot twist. ESA's Trace gas orbiter, equipped with more sensitive instruments, has repeatedly failed to confirm these methane spikes from orbit. It's as if Mars is exhaling just enough gas for Curiosity to catch a scent, but nothing more. Geology offers a lifeline to skeptics. Certain minerals, like olivine, can react with water and carbon dioxide to produce methane without any biology involved. Or perhaps ancient methane, trapped in icy clathrates underground, is leaking through cracks when the ground warms. But even these explanations strain under scrutiny. Why the seasonal patterns? Why the sharp spikes instead of steady seepage? Enter Perseverance. The rover's mission includes sniffing for organics and drilling samples that might one day return to Earth. Yet Mars isn't the only place hunting for methane secrets. Jupiter's moon Europa, with its subsurface ocean, could be an even likelier haven for life. Plumes of water vapor and possibly methane erupt from its icy shell, hinting at chemistry stirring in the darkness. If Europa's methane carries isotopic signatures only biology can produce, it might steal Mars's thunder as the prime candidate for extraterrestrial life. For now, Mars keeps its secrets close. Every new reading adds another layer to the puzzle, a whisper of gas, a tantalizing pattern, and the gnawing possibility that we're either on the brink of discovery or chasing a cosmic mirage. One thing's certain: methane is more than just a molecule on Mars. It's a ghost, a clue, and maybe, just maybe, the first ripple in a much larger story. And if untangling the chemistry of a distant world feels dizzying, wait until you meet a place where the laws of physics seem to rewrite themselves by the hour. 16th Enigma, Europa's hidden ocean life beneath the ice. Beneath Europa's frozen crust, a secret sea churns in perpetual darkness. This icy moon of Jupiter hides an ocean twice the volume of Earth's, an abyss locked under miles of ice, yet warmed by the relentless gravitational tug of its giant parent planet. Most oceans need sunlight to thrive. Europa's defies that logic. Here, heat comes from below as tidal forces flex the moon's core, keeping the water liquid against all odds. And where there's warmth, water, and chemistry, there's a tantalizing possibility. Life might already be stirring in those depths. The clues are as dramatic as they are elusive. Hubble's snapshots caught towering plumes of water vapor erupting from Europa's south pole, geysers spewing material hundreds of miles into space. These aren't just icy fountains, they're potential samples ejecting traces of the hidden ocean into the void, ripe for study. Future missions like NASA Europa Clipper aim to fly through these plumes, analyzing their chemistry for organic molecules or even cellular building blocks. Imagine dipping a cup into a geyser and finding it brimming with alien microbes. But Europa isn't the only icy world flaunting its secrets. Over at Saturn, the tiny moon Enceladus puts on a similar show with a twist. Its southern geysers aren't sporadic. They're constant, feeding Saturn's ring with ice particles and organic rich vapor. Cassini's daring dive through these plumes in 2017 revealed hydrogen gas, a chemical signature that, on Earth, often comes from hydrothermal vents teeming with life. The parallels are irresistible: two moons, two hidden oceans, two shots at answering whether life exists beyond our planet. Yet mysteries remain. Europa's ice shell, up to 15 miles thick in places, could shield its ocean from harmful radiation, but also isolate any potential ecosystems from easy detection. Enceladus, smaller and more active, might churn its ocean's contents to the surface more efficiently. Which moon offers the better gamble for astrobiologists? Europa's vast ocean has more real estate, but Enceladus hands us its ingredients on a silver platter. The search isn't just academic. If life thrives in these sunless abysses, it would prove that biology isn't a fluke of Earth's gentle conditions. It's a cosmic imperative, capable of sparking even in the most hostile corners of the universe. And if these oceans are sterile, that silence would be just as profound, forcing us to confront the eerie possibility that our pale blue dot might be utterly alone. Either way, the answer lies beneath the ice, waiting for us to take the plunge. And while we're peering into alien oceans, another cosmic rebel demands attention. One that doesn't just hide its secrets, but actively erases them. 17th Enigma. Enceladus's hydrothermal vents a recipe for life. While Europa's ocean hides in shadow, its smaller sibling, Enceladus, flaunts its secrets in dazzling plumes. this tiny Saturnian moon, no larger than Arizona, should be a frozen wasteland. Instead, it's a cosmic fire hose blasting water vapor and organic compounds into space from fractures near its south pole. But the real marvel lies beneath, a global ocean kept liquid by Saturn's relentless gravitational squeeze, where hydrothermal vents may churn in the darkness just like those on Earth's seafloor. And where there's heat, chemistry, and liquid water, life might not be far behind. The smoking gun came from NASA Cassini probe. As it skimmed through Enceladus's geysers in 2017, its sensors caught hydrogen gas, a telltale byproduct of water reacting with rock in scalding underwater vents. On Earth, such vents cradle entire ecosystems, thriving in pitch-black depths without a trace of sunlight. Tube worms, blind shrimp, and bacteria build their existence around these mineral-rich chimneys, powered not by photosynthesis but by chemosynthesis, the art of turning chemicals into energy. Could Enceladus host a similar silent revolution? The ingredients are all there: methane, carbon dioxide, ammonia, even complex organic molecules like benzene. It's as if this moon bottled Earth's primordial soup and left it simmering. Yet puzzles remain. Enceladus's plumes vary in intensity, sometimes surging, sometimes fading, as if the moon breathes in erratic rhythms. Are these changes driven by shifting ice quakes or something more dynamic beneath the crust? Worse, hydrogen alone doesn't equal life. It could just signal sterile geology at work. The clincher would be detecting phosphorus, a key element for DNA and RNA, or better yet, amino acids with a specific molecular twist that only biology can produce. Future missions could settle the debate. Proposed spacecraft like Enceladus Lifefinder would dive through its plumes with sensors fine-tuned to sniff out biosignatures. But even if the vents prove barren, their existence rewrites the rules. Enceladus shouldn't have the heat or chemistry to sustain such activity. Its defiance hints that icy moons across the galaxy, even those far from their stars, might harbor oceans of their own. And while we search for life's fingerprints in our solar system, another frontier beckons, one where planets refuse to follow the script. Beyond our sun's influence, worlds orbit in impossible configurations, defying every expectation astronomers once held. 18th Enigma. Rogue planets, the ghost worlds adrift in darkness. Most planets obey the cosmic rulebook. They circle a star, basking in its warmth, their orbits as predictable as clockwork. But not these rebels, drifting alone through the void, untethered to any sun. Rogue planets are the galaxy's ultimate nomads. No daylight, no seasons, just perpetual night, and yet they might be the most common worlds of all. Astronomers suspect these cosmic orphans outnumber stars 20-1, a silent majority lurking in the dark. How does a planet end up alone? Some get violently evicted from their stellar nurseries, flung into the abyss by gravitational tugs of war with sibling worlds. Others might form directly from collapsing gas clouds, never knowing the warmth of a star. But the real shock isn't their origin, it's what they might hide. Without a sun's heat, you'd expect these worlds to be frozen wastelands. Yet deep beneath icy crusts, tidal forces or radioactive decay could keep subterranean oceans liquid for billions of years. Imagine entire ecosystems thriving around hydrothermal vents in eternal darkness, just like Earth's deep sea extremophiles, except these creatures would never know a sunrise exists. The hunt for these invisible worlds is rewriting astronomy. Using microlensing, a technique where a rogue planet's gravity briefly magnifies the light of a distant star, we've caught glimpses of them. One, dubbed Ogle 2016 BLG 1928, may be the smallest free-floating planet ever detected, barely larger than Earth. Future telescopes like the Nancy Grace Roman Space Telescope will scan for thousands more, mapping this hidden population. But rogue planets aren't just curiosities, they're time capsules. untouched by stellar radiation, their atmospheres, if they have any, could preserve pristine samples of the early universe's chemistry. Some might even carry hitchhiking microbes frozen in suspended animation between stars, turning panspermia into an interstellar relay race. What's truly unsettling? If intelligent life arose on a rogue planet, its sky would be eternally black. No sunrises, no constellations, just the faint glow of distant galaxies. Their concept of the universe would be unimaginably different from ours. And as we scan the darkness between stars, we're left wondering, could the galaxy's dominant life forms be huddling in the warmth of radioactive rocks, utterly unaware of the light we take for granted? While rogue planets redefine what a world can be, another cosmic oddity takes the mystery deeper, into realms where the very laws of time and space twist beyond recognition. 19th Enigma. The Great Attractor, the cosmic force we can't see our galaxy, isn't floating aimlessly through space. It's racing toward an unseen force at 14 million miles per hour. This isn't just random motion. Something colossal is pulling us in, and the strangest part, we can't even see what it is. Hidden behind thick curtains of dust and stars in the zone of avoidance, a region so obscured by the Milky Way's own bulk that telescopes struggle to peer through, lies the Great Attractor, a gravitational anomaly so powerful it bends the paths of entire galaxy clusters. The first clues emerged decades ago when astronomers mapped the cosmic flow of galaxies and noticed something unsettling. Everything around us, from the Milky Way to distant superclusters, is streaming toward a single point in the constellation Centaurus, as if the universe itself were tipping into an invisible drain. Calculations suggested a mass equivalent to tens of thousands of Milky Ways must lurk there to exert such a pull. But when scientists pointed their instruments in that direction, they found nothing obvious. Just the Norma cluster, a gathering of galaxies impressive by normal standards, but nowhere near massive enough to explain the phenomenon. So what's really there? One theory suggests the Great Attractor is merely the tip of a cosmic iceberg, the visible edge of an even larger structure called the Laniakea supercluster, a vast web of galaxies spanning 500 million light-years, with our Milky Way perched on its outskirts. In this model, we're not being pulled by one single object, but by the combined gravity of countless galaxies, dark matter, and cosmic filaments in a gravitational dance too complex to untangle easily. But there's a twist. Some observations hint that the Great Attractor might not be the final destination. It could be a waypoint on a much longer journey toward an even more massive anomaly, the Shapley supercluster, a staggering 800 million light-years away. If true, it would mean we're caught in a tug-of-war between titanic forces, with dark matter's invisible hands guiding the motion. The mystery isn't just academic. Understanding the Great Attractor means unraveling one of gravity's deepest secrets: how dark matter sculpts the universe on the grandest scales. New telescopes like the Square Kilometre Array aim to pierce the zone of avoidance with radio waves, peeling back the cosmic dust to reveal what's really out there. Until then, we're left with a humbling thought. Even as we map the cosmos, some of its most powerful forces remain just beyond our sight. And if hidden gravity can reshape the universe's architecture, wait until you witness a place where time itself warps beyond recognition. 20th Enigma. Quantum gravity, the universe's missing rulebook. Picture two rulebooks for reality, each flawless in its own domain, yet utterly incompatible when forced to share the same page. On one side, Einstein's general relativity governing the cosmos with its elegant warping of space-time. On the other, quantum mechanics dictating the chaos of particles with probabilistic finesse. Both work perfectly until they collide, at the edge of a black hole or the first instance of the Big Bang, where infinite density meets quantum uncertainty. The laws of physics as we know them break. And that's the problem quantum gravity aims to solve, stitching these two theories into a single framework that explains everything. The clash isn't just academic. When relativity says a black hole singularity crushes matter into oblivion, quantum mechanics insists information can't vanish. When the Big Bang's equations point to an infinitely dense time zero, quantum fluctuations suggest something must have come before. These aren't minor gaps, they're foundational ruptures in our understanding of reality. So how do we mend them? One leading contender is string theory, which replaces point-like particles with tiny, vibrating strings. These oscillations could unify all forces, even gravity, under one mathematical roof. But there's a catch. Strings demand 11 dimensions, 7 of which are curled up too small for us to perceive. It's a breathtaking idea, yet after decades, no experiment has confirmed it. Critics argue string theory has drifted into metaphysics, its elegance untethered from testable predictions. Enter loop quantum gravity, a radical alternative that chops spacetime into discrete, woven loops, a cosmic fabric woven from indivisible threads. Unlike string theory's extra dimensions, loops operate in familiar 3D space, offering a tangible portrait of quantum spacetime. But here, too, challenges loom. Loops struggle to reconcile with relativity's smooth cosmic curves, leaving some to wonder if the truth lies somewhere in between. Then there's the holographic principle, a mind-bending notion that our 3D universe might be a projection of information encoded on a 2D surface like a cosmic QR code. Black holes, with their mysterious information paradox, hint at this duality. Their event horizons could store data like a hard drive, rendering the interior an illusion. If true, gravity might not be fundamental at all, but emergent, a side effect of deeper informational layers. The stakes couldn't be higher. A working theory of quantum gravity wouldn't just tidy up physics, it could reveal new cosmic chapters. Did spacetime have a beginning, or is it part of an eternal cycle? Are wormholes stable gateways or mathematical mirages? Could the universe itself be a simulation built on quantum code? For now, the hunt continues. Particle colliders probe energies that might unveil hidden dimensions, while telescopes scour black holes for holographic fingerprints. Somewhere in the noise between theory and observation, the missing rulebook waits. And when we find it, reality might look nothing like we've assumed. But if stitching together spacetime feels daunting, brace yourself for an even deeper rabbit hole, one where the universe's very constants might not be constant at all. 21st Enigma. Time's illusion, the universe without a clock. We like to imagine time as a river, always flowing in one direction, carrying us from the past toward the future. But the deeper we probe the fabric of reality, the more that metaphor falls apart. Quantum mechanics, with its eerie experiments, paints a far stranger picture, one where cause and effect aren't just linked, they might even reverse. Particles entangled across space seem to influence each other instantaneously, as if time is a suggestion rather than a rule. And if that's true at the smallest scales, what does it mean for the cosmos itself? Take the delayed choice quantum eraser experiment. In this mind-bending setup, a photon's decision to behave as a particle or wave appears to rewrite its own past actions, as if the present reaches back to tweak history. It's not time travel in the sci-fi sense, but something subtler, evidence that time's arrow might not be as rigid as we thought. Some interpretations suggest reality only solidifies when observed, with past and future existing in a fluid state until measured. Then there's the block universe theory, championed by Einstein himself. Here, time isn't a progression but a static landscape, an unchanging block where past, present, and future all exist simultaneously. Your birth, your death, and every moment in between are already out there, like frames in a film reel waiting to be projected. This isn't just philosophy, it's math. Relativity treats time as a dimension no different from space, where now is relative to the observer. A star exploding a billion light-years away might already be dead in our past, but for a civilization near it, the explosion is their present. Yet the most unsettling hints come from cosmic voids, vast, empty regions where space-time seems to warp unpredictably. In these deserts where gravity's grip is weakest, time might literally stretch or stutter like a record skipping. Could these voids be windows into a deeper truth that the universe doesn't flow at all, but simply is? The implications are dizzying. If the past isn't fixed, could future events ripple backward to shape it? Are memories and fossils just illusions flickering into coherence when we look? Even black holes, those destroyers of time, might hold clues, their event horizons acting as cosmic sensors, hiding the truth of what time really is. One thing's certain, our intuition about time is built for survival, not physics. And if the universe laughs at our calendars and clocks, the next enigma might shatter reality even further, where the very laws of nature aren't laws at all, but fleeting habits of a much weirder cosmos. 22nd enigma. The Eridanus Supervoid, the universe's cold spot, most of space teems with galaxies, stars, and the hum of cosmic activity, but not this place. Stretching an astonishing 1 billion light-years across, the Eridanus Supervoid is a near-perfect sphere of almost nothing. It's not just empty, it's colder than its surroundings, as if someone turned off the heat in a corner of the universe. And the strangest part, this cosmic blank spot might hold clues to realities beyond our own. The mystery begins with the cosmic microwave background, the afterglow of the Big Bang. When scientists mapped its temperature, they found a chilling anomaly. The Eridanus region is noticeably cooler, as if something siphoned away its energy. Voids this large should barely affect the CMB, yet here, the temperature drops by 70 microkelvin, a tiny number with enormous implications. So what's stealing the heat? One theory dips into the multiverse. If parallel universes exist in a higher dimensional foam, their gravity might subtly tug on ours, leaving imprints like this void. Picture pressing your finger into a balloon. The dent isn't part of the balloon's fabric, but the mark of something outside it. Similarly, the supervoid could be a bruise from a cosmic collision, another universe brushing against ours in the dark. Yet skeptics argue it's just a statistical fluke, a random low-density region magnified by our imperfect view. After all, the universe isn't uniform, matter clumps and thins like froth on an ocean. But simulations struggle to produce voids this vast naturally. Even dark energy, the usual suspect for cosmic expansion, doesn't easily explain such a perfect energy-draining sphere. The truth might lie in the void's sheer scale. If the supervoid is real and not an illusion of overlapping smaller voids, it challenges our models of how structure forms. Galaxies should flee its emptiness, yet some surveys hint at unexpected clusters lingering at its edges, like debris caught in a whirlpool's calm center. Are these outliers flukes or hints of an unseen force sculpting the void from within? Telescopes like the Atacama Cosmology Probe are scrutinizing this cosmic cold spot, searching for polarization patterns that could reveal its origins. Whether it's a multiverse fossil or a quirk of statistics, the Eridanus Supervoid forces a humbling lesson. Sometimes the universe's loudest secrets hide in its quietest places. And if an absence this vast can rewrite the rules, what other invisible wonders are waiting to be uncovered? But while voids whisper of missing energy, our final enigma takes us to the edge of comprehension, where the very laws of physics might be unraveling before our eyes. 23rd enigma. The simulation hypothesis, reality's hidden code. What if everything around you, the stars, the laws of physics, even your own thoughts, were lines of code in an unfathomably advanced simulation? It sounds like sci-fi, but some of the brightest minds in physics and philosophy take this idea seriously. The simulation hypothesis suggests our universe might not be the base reality, but an artificial construct engineered by some higher intelligence. And the eerie part, there's actual scientific reasoning behind this wild possibility. Start with quantum mechanics. At the smallest scales, particles don't behave like solid objects, they exist in probabilities, collapsing into definite states only when observed. It's almost as if reality renders itself on demand, like a video game optimizing graphics only where players are looking. Then there's the uncanny precision of the universe's constants. The speed of light, the strength of gravity, tweak any of these values slightly, and stars, planets, and life itself would never form. Such fine-tuning has led some to wonder, are these laws just carefully chosen parameters in a cosmic program? Even mathematics, the language of physics, hints at something strange. The universe seems to run on elegant, discoverable equations, as if it were designed with logic in mind. Max Tegmark's mathematical universe theory takes this further, proposing that reality isn't just described by math, but is math. In this view, our cosmos could be one of countless possible structures in an infinite computational landscape. But if we're in a simulation, who's running it? Future humans, alien superintelligences? Some theorists suggest a civilization just a few centuries ahead of us could have the computing power to simulate entire conscious worlds. Others propose a more existential twist. Our creators might themselves be simulations, nested in an endless digital regression like cosmic Russian dolls. The implications are dizzying. If the simulators ever choose to turn off the program, would we even know? Could glitches in reality like déjà vu or quantum anomalies be bugs in the code? And what's the point of it all? A research project, an ancestor simulation, an experiment in consciousness, skeptics counter with Occam's razor. The simplest explanation that reality is real is usually correct. Yet the debate persists because at its core, the simulation hypothesis forces us to confront the nature of existence itself. It's the ultimate meta-mystery, weaving together every cosmic enigma we've explored. Dark matter may be just background processes, quantum uncertainty, rendering limitations, the Fermi Paradox the simulators didn't code in other civilizations. Whether you find the idea terrifying or thrilling, one thing's certain. If reality is a simulation, the greatest discovery wouldn't be finding the programmer. It would be uncovering the rules they broke to make it feel so real. And that, perhaps, is the most profound puzzle of all. Conclusion: the unfinished symphony of the cosmos, dark matter's invisible grasp, black holes swallowing reality, rogue planets drifting in eternal night. What ties these puzzles together isn't just their strangeness, but what they reveal about us. The more we uncover, the clearer it becomes. The universe isn't just a collection of facts to memorize, it's an invitation. Every unanswered question, every cosmic contradiction, is a doorway to something grander. Think of these 23 enigmas as pieces of a mosaic we're still assembling. Some fragments fit neatly, like the way quantum mechanics explains the tiny or relativity charts the vast. But the gaps between them, that's where the magic lies. The thrill isn't in having all the answers, it's in standing at the edge of the unknown, flashlight in hand, knowing there's always another layer to peel back. And that's the real wonder. Whether you're mesmerized by the Fermi Paradox's eerie silence or the simulation hypothesis's existential twist, these mysteries aren't just science, they're mirrors. They reflect our persistence, our creativity, and that restless itch to look up at the stars and ask, what else is out there? So tell us, which of these cosmic riddles keeps you up at night? Is it the phantom pull of Planet 9 or the coded whispers of fast radio bursts? Drop your thoughts below, and if you're hungry for more deep dives into the universe's secrets, hit subscribe. Because the cosmos isn't done surprising us yet, and the next revelation, it might be just one observation away.